Hello, welcome back to my YouTube channel. This is Mr. Mohammed Ibrahim. Today I'm going to start a new videos about computer science 0204778. So I'm going to solve the May June 2023 paper, and for this paper, the time duration for this paper is 1 hour 45 minutes, as you see, and this paper is about answering questions. This is a theoretical paper, so you must answer all the questions. All questions must answer. You can use black pen or blue pen only for this exam, and you can use a HP pencil. No calculator is uh, enabled is on this paper, and you must use your mind for the calculation. So this is it, the information about the paper. The total of this paper is 75 mark. You will find each mark for each question below in package. So this is about the information about this paper. So I'm going to start with solving the paper. So the examiner, he said a binary is number system used by computer. He say a trick uh, one of the box show which statement about the binary number is correct. It is base 1 system, or it is base 2 system, it is base 10 system, and base 16 system. The base 16 system is hexadecimal, and it is start from 0 finishing with F. It's 15 digits, and we mention it by hexadecimal. For the 10 system, this is we use it for the denary number, and it starts from 0 ending with 9. This is for the denary number. We don't have any base 1. For base 2 is content of zeros and ones, and this is the system of the computer. So the correct answer is base 2 system. So going to the next question, he said convert no denary number are converted to binary number to be processed by the computer. He said convert the 3 denary number to 8-bit binary, and you must show your work and give your final answer in here. So to do this, simply I'm going to start with my work area down here. So I'm going to go down here and write on. First I'm going to write down the numbers that I need: 1, 2, 4, 8, 16, 32, 46, excuse me, 32, and 64, and 128. I'm going to put the 15 here equal, and the 1, 2 equal, and the 201 is equal. So I'm going to see how I can get the 5 from here by adding zeros onward. So to get the 50 is a combination of between the 32 and the 16. This is give us 84 if we add them together. And to have the 50, you have to add the 2 for them to be 50. So 0 in here, 0 in here, 1 in here because we use the 32, and 1 in here because we use the 16, and 0 in here, 0 in here, 1 from those, and 0 from those. So this is how we can find the digits. So I'm going to put this in a box to make it clear. So this is the 1, 2, this is the 8-bit register, 8-bit register. So For 102, I'm going to use the 64 and the 32. If I'm using the calculator, let me use the calculator. For you in exam, you don't able to use the calculator. I'm not able to use the calculator, so I'm going to. What is the calculator? Let me see. Calendar calculator. This is the calculator. I'm going to put it down here. So I'm going to add the 64 to the 32. It's give me 69. So to have the 102, you have to add 4 to it. If I add 4, this give me 100, and I need to be 100. So simply, I'm going to put 1 in here, 1 in here, 1 in here, and 1 in here. So the rest are zeros. For the rest are zeros. So for the 102, I'm going to use the 128, and I'm going to use the 64, and we don't need to use the 32. So I'm going to use the 16, 8, 4, 2. I don't need to use 2, and I'm going to add the 1. So let me show you how I get this answer. So simply from the calculator, let's add them together. Let's add 128 plus the 64 plus the 8 plus 4 plus 1. Give me 1. Oh, this give me excuse me, let me add it again. 108 plus 64 plus 16 plus 8 plus 4 plus 2 plus 1. So it's give me 102. So the final answer for my question is 0 0 1 1. You can see it here 0 0 1 1 0 0 1 0. And for the 102, you give 0 1 1 0 1 1 0. And finally, for the 202, we have 1 1 0 triple 1 1 0 1. So this is the final answer how it's supposed to look like. You do this, you will get the full marks. We have 3 marks in here. So I'm going to continue with the rest of the question. So in C, you say binary number are stored in a register. So we use a register back in this question to solve the converting of the binary number to a binary number. So I'm going to put 128 in here, 64 in here, 32, and 16, 8, 4, 2, and 1. So this is give me 255 for the 8-bit register. So we say a binary number are stored in a register. Okay, negative binary number can be represented as a binary number using the tools complement. Complete the binary register for the binary number negative 78. So whenever we had a negative number, so that means the last digit in my register is a negative number. So we say complete the binary register for the binary number negative 78. You must show all your work. So this is a space of our work. So simply to answer this kind of a question using the two's complement. So for the last digit 128, I have to add it to the 64 to see if it give me an the number negative 70 87 or the nearest number to it. So to do this, I have to add the 128 to the 64, and it's give me negative 64. So that's mean I use the 64 uh, register for this counting for the 0 in here because it's negative, so I have to put 0 in here. So it's giving me a near number to negative 76. So let's see if I put negative 70, negative 64 to 32. It's give me, so adding those together, it's give me negative 96. Negative 96 is too far from the number, so uh, going into add the negative 96 to the 16 plus 16, it gives me minus 80. So minus 80 is very near number to negative 78. So from negative 80 to get the negative 78, you have to add 2 to this counter. So I'm going to put 2 in here, and I'm going to put on the 16 in here, and I don't need the rest of them. So this is how you can answer the question of the register. So we have 1 here because we have used the 32 up here to find my number. So this is how you can answer the two's complement question. So this is your register, how it should look like. And if we add those numbers together, if I add 2, so 2 plus 16 plus 32 plus 64, and I add minus 128 to it, it's give me negative 78. So this is your final answer. So this is how you can answer a question of two's complements on this paper. So going into the next question, we say in B, 2-bit, 8-bit binary number are given. Add the 2-bit binary number using a binary addition. So I'm going to do the addition for those two numbers. Simply, we have the rules of addition. We know that 1 plus 0 is give me 1, and 0 plus 1 is give me 1, and 1 plus 1 is give you 0, carry of 1, and 1 plus 1 plus 1 is give me 1, carry of 1. So to do this, simply 1 plus 1 is 0, carry of 1, and 1 plus 1 is 0, carry of 1, and 1 plus 0 is 1, 0 plus 0 is 0, 1 plus 0 is 1, and 1 plus 1 is 0, carry of 1, and 1 plus 1 is 0, carry of 1, and 1 plus 0 is give me 1. So this is my final answers look like this: 1 0 0 1 0 1 0 0. You do this, you get your full mark for this question. So simply, that's easy and nice. So moving to the next question. The examiner in E, he said, explain. He said two binary number are added by the computer and overflow error occurs. He said, explain why the overflow error occurs. Yeah, to give him a very clear answer of a 2 point. So simply to do this, it's easy, and to do it, start with give your register. Let's say 1 2 4 8 16 16 32 46 and 1 2 8. Okay, if I have my register, this is the register. The combination of the addition of those registers together is give you 255 bit. Okay, so this is if I put one on all of those uh, places. That means all of them are on. So if I add one, just add one to it. So 0, 0, 0, 0, 0, 0, 0, and 1. So let's give the answer of adding those together. 1 plus 0 is 1. 1 plus 0 is 1. 1 plus 0 is 1. 1, 1, 1. 1 plus 0 is 1. And 1 plus 1 is 0 carrying of 1. So let me just 1, 2, 3, 4, 5, 6, 7, and 1. And the last digit is 1 plus 1 is 0 carrying of 1. So the last digit is 0 carry 1, 2, 3, 4, 5, 6, 7, 8, 9. No, I have to put the 9 0. Excuse me. 0 carry. So if I count them 1, 2, 3, 4, 5, 6, 7, 8, and we have 9 here. We said that the combination or the addition of those is give me 255, right? So this number is not 255. So I'm going to see that I have an overflow digit here, give me 9 bits. So this is the overflow digit. So that you see is my register cannot store this bit in here, and it's too large from the 8-bit register size. So I'm going to give him two reasons. So number one, the result, you see it in here, is greater than 255, because we have another digit shown, or overflow digit is shown in here. Number two, you can also say that is too large to store. It's too large to be stored. Number three, also we can say that is register its request or require more than 8-bit register. So this is how you can answer an explanation question. This one in the left is just an explanation of the how you can see the overflow in the addition uh, in the addition of adding two binary number together. So this is how you can answer this question. So here in question 2, the examiner say a student has a sound file that is too large to be stored, or on their external external secondary storage device. The student compressed the file or the sound file to make the file smaller. So in here he said the compression method used reduce the sample rate and the sample resolution of the sound file. State what is the mean by the sample rate and the sample resolution. As you know, the sample rate is simply uh, the number of the number of sample that taken in 1 second. So I'm going to write down here the sample rate is the number of sample taken uh, in 1 second. 1 second. So this is what we mean by sample rate. For a sample resolution is the number of bit per sample. So I'm going to write down the number, the number of bit per sample. So that is the explanation of both of those. So in D, he say identify which type of compression has been used to compress the file size. To compress the file size, you have two type of compression. The first is loosely and loosely. Loosely and loosely. So loosely is reducing the file without retaining the original file, but loosely is fixing the problem of loosely. So he said, the examiner up here, he said that this student is using compression to reduce the file. So that means he used a lossy compression to reducing the file size. So the compression type here is lossy compression. Lossy compress. So I'm going to write down lossy compress as an answer for my question. So in C, he say a student sent a sound. He say a student sent a sound to his friend. The file is transmit across the network that use packet switching. Identify two pieces of data that would be included in a header of each packet. So the header is contain two types: the destination and the receiver, the sender and the destination IP, and also it contain of the number of packet number. So those are the things that you find in the header. So I'm going to write down in here as an answer the packet number, or also I can need the destination or the receiver IP address. So this is my answer is. So this is how you can answer this question. In part 2 of the question, he say explain how the file transmission is using packet switching. So you need to explain how it used. As you know, the packet is must, as an answer for the first one, you have to give, let me see here, 5 reasonable answers. So the first one, the packet, the the packet is split to uh, the data, not the packet. The first thing we need to know that we have in the data. So the data is split into pocket into pockets. So this is the first step. Secondly, each pocket take a different road, and this road is controlled different thought. This road, the node or road or we call it the node or the road controller is the road controller is control the packet flow for each packet number. So this is the answer for number three. So number four, packet could arrive. This my packet could arrive with an error or unordered. The packet could arrive unordered. Uh, we need to make sure we reorder the data. Lastly, the last thing, once the data is arrived, packet is put into correct order. So this is how the transmission happen. First, we split the data into packets, and then we should let the root controller decide which way must each of those packets take, and may sometimes find them reordered. So if we mention that is this one, two, three, and four, they might come 4, 2, 3, and 1. So the root controller makes sure that he reorder this number in here, and the data is being checked at the end. If there is any mistake, they will fix this mistake and put the bucket in the correct order. So this is, you can answer this question. So question number 3, he say a secondary storage device are used to store the data in the computer. Circuitry component that they are secondary storage device. So we have the register is internal, the sensor is secondary but is not for storing the devices. So we have a uh, solid state drive. It's a secondary storage device. Also we have the hard disk drive. It's a secondary storage device, and You may confuse it about the register on the disk, compact disk. So the compact disk is external device. So this is my answer. Yes. So in the next question, he said, tick one of the showing, which is said about the secondary story is correct. So in A, it is directly accessed by the CPU. Two, it is magnetic storage only. Number three, it is used to primarily store software and data files, and it is a wallet. So a wallet is for ROM. This one is for ROM, and magnetic is not used in here. Directly accessed by the CPU. This is a microprocessor, and our answer must be C. It is used primarily storage device and data file. So this is a statement of a secondary device. So my answer will be C. So going into the next question, the examiner in number 4, he said complete the statement about the different type of the software. Use the term from the list. So we have in a list here, we have to put the right one on here, and here, here, and here, and here. So software provide the service that the computer requests. An example, it is a utility software. You know that the utility software is provided by the system software. So I can write down here, if we have system, yeah, we have a system, I can write down system software provide the service that the computer require. An example, it is a utility software. So this is the software system that we need. This is the first answer. So he said software is run on the operating system. Of course, the application or the software who are running on the operating system. So I'm going to write application. Application software is run on the operating system. The dash system is run on the firewall. What is running on the firewall? As we know, system, the operating system is run on the firmware, which is run on the hard disk. Anything, the software is run on a hard disk, so I'm going to write hard disk in here. So those are my answer is system software provide the system that the computer requires. For example, the utility software. So this is the system. So application software are run on the operating system, and the operating system is run on the firewall, which is run on our hardware. So this is the final question for my answer. So I'm going to stop on here. Thank you very much for watching my video. If you have any question, please give it to me in the comment below. This is Mr. Muhammad Ibrahim. Thank you very much for watching my videos. Have a good time and bye.